This is Professor Darif Seitz. Percentiles. This video shows how to quickly calculate percentiles using Microsoft Excel. The concept of percentiles is to take a data set and to partition it into 100 equal partitions, equal tiles that don't overlap, and when they're put end to end, they make up the whole data set. A partitioning or a tiling of the data set into 100 parts. Some challenges of doing that is if your data has fewer than 100 items, how do you deal with it? Greater than 100 items? And even more problematic is, what if there are items that are repeated with the same value? How does that work? And because of these challenges, different technologies have different algorithms that they use. There's slightly different to calculate percentiles. I will be showing here what Microsoft Excel does with their system. The data for this spreadsheet is the blue cells. You have to enter it here or copy it, and they should be sorted. It's important that you sort them in order to be able to do some of the things that are needed, some of the values that are needed to be entered here, as we'll see momentarily. This data has 20 items from row 2 through row 21, and it represents exam scores. Low score of 20, going all the way up through a high of 73. So this was either a tough exam or the students didn't study. But in any case, it's a good example. First thing we want to look at is the concept of quartiles. There's 3 quartiles, Q1, Q2, and Q3. They are particular percentiles. Q1 is the 25th percentile, Q2 is the 50th, and Q3 is the 75th percentile. That means Q1 is the dividing point in the partitioning where 25% of the data is below it. Q2, 50% is below it, which means 50% is above it. And Q3, 75% is below it. These are called quartiles. First, we'll look at Q2. Q2, being in the middle, is the same as the median of the data set. However, we'll use the Microsoft Excel function here. Quartile.inc stands for inclusive, and you give the range of the data and the quartile number as the second parameter here, 2. And 67 is the quartile 2 cutoff. Notice there's 2 67s here. Quartile 1, same function, but with a 1 parameter at the end. Quartile 3 has a 3 parameter at the end. There's something called the interquartile range, IQR, and it's defined to be the difference between Q3 and Q1. Calculation here simply subtracts those 2 values to get the interquartile range. Now, looking at percentiles themselves, besides those prominent quartile ones, we'll look here. If we enter a percent that we're interested in as a decimal number, in this case 90, entered as a decimal, 0.90, we can have an answer come out, the percentile that corresponds to that point, that division point, that 90th percentile. What data value corresponds to it? And it's the percentile.inc function. There's your data, and D8 here has to be your percentage that you're looking for, 90, and the answer that comes out is 72.1. 72.1 is between 72 and 73, so that's the cutoff for the 90th percentile for this data set, which means 90% of the data lies below that cutoff point. Going in the other direction, here we start. We need 3 blue cells. Data needs to be entered. First, an X value itself. we'll enter 73, which is way down here, and there's two of them. Enter a 73. Next, the number of data values less than X. To get that, that's why you need the data sorted. Highlight the data below 73 right there, and look in the status bar over here. It tells you there's 18 things selected, and then you enter 18. So just sort and count to get that value to enter. And then the total number of values in the data set, you look there and see that there's 20. This cell, what does it do? It takes D12 divided by D13. That's the number of values that are less than the X divided by the total number of values. That gives you a ratio of percent, and you multiply that by 100 to bring it out of the decimal realm into a percent whole number, and round it, and you get 90. So 90% here. A score of 73 is the 90th percentile. And this is where a misunderstanding can easily happen with this concept of percentiles. Normally, you would not think of an exam score of 73 as being in the 90th percentile. You would think of scores that are in the 90s as being the 90th percentile. But remember, the underlying concept is partitioning the data as it exists. This data, 73, there's two of them, are the highest values. And so 90% are below those. And it's important that you get that difference so you are not confused by the concepts of percentiles. Over here, there's two other calculations that are done here. It's commonly defined that an outlier will be start at values that are quartile 1 minus 1.5 times the IQR. So those are all to the left. If you get that far out or further out, you're considered to be an outlier. So here is a calculation to do this Q1 minus 1.5 IQR using the other cells here. And on the right-hand side, right-hand outliers are Q3 plus 1.5 IQR. So on the left side, 41.8 something, the 20 is an outlier, according to this definition of outliers. 88.8, we don't have any outliers on the right.